Okay, so today we're going to get into chapter 6, which is on functions and basically operations you do with functions. And so first of all, we're just going to look at this chart. Like I said, I don't know if it's that important that you write it down because I think from looking at the chart you'll see that it's really not that bad. Basically, this addition property, what it states is that if you have two functions, all you have to do is just add each individual function together, add its component parts. Okay? If you want to subtract two functions, you just subtract each of the corresponding parts. Same way with multiplying. You're going to multiply the corresponding parts. And then last but not least, division. You're going to divide the two functions. Biggest thing you need to focus on here is this statement right here. G of x cannot equal 0 because you can't divide by 0. Remember, that's undefined. And so real quick here, if I look, my two functions are 2x and negative x plus 5. So if I want to add f of x plus g of x, this is all I do. I add the 2x and the negative x, and I get x. And then I have my plus 5. If I subtract the two, notice I put a subtraction sign outside of the second. You have to distribute that subtraction sign to each so that really I end up having plus and minus. So I end up getting 3x minus 5. Here, I'm going to distribute the 2x to each. And then last but not least, all I'm going to do here is divide. Biggest thing you need to understand is this statement right here. Where does it come from? Negative x plus 5 equals 0. That's all we're doing is setting it equal to 0. So if I subtract 5, I get negative x equals negative 5, or x equals 5. Okay, and so we're saying x can't be 5 because then that denominator will be 0. So we're going to look at 4 of these in class real quick. It says, given f of x equals x squared minus 4 and g of x equals 2x plus 1, find each function. Indicate any restrictions on the domain. You only have to worry about this statement when you divide. That's the only time. Okay? So first of all, let's just start with f plus g of x. Basically, all that means is I'm going to take f of x and I'm going to add g of x. That's all I'm going to do. So let's see, are there any like terms? The negative 4 and the 1. So my x squared and 2x stay the same. And then what do I have? Minus 3. There you go. That's it. There's no catch. All right, that's pretty much all you're doing.
Wait, just get more.
Okay, so on the next one it says f minus g of x. So I'm going to do the exact same thing I did in the previous problem, except for instead of adding, I'm going to subtract. So the only thing I need to worry about here is I need to worry about distributing the negative sign. So to distribute that negative sign, I'm going to make that a negative 2x and a negative 1. So what is your answer going to be then? X squared minus 2x minus 5. And yes, you do need to put it in descending order. Okay, so I want highest power, I want the next highest power, and then the constant. So far, what do you think? Okay, let's look at the next one. Now we're going to times them. Now, if you notice, these are a little different. I just threw 2 new functions in there. Same thing. All I'm going to do is multiply these 2. Now notice it says indicate any restrictions on the domain or in the domain. When do I worry about that? When it's division. I don't worry about it any other time. Okay?
So in the second one?
So in the second one's the only time I have to worry about it. Yep. So let's go ahead and start with the first one. It says f, so x squared plus 5x minus 2 times g, which is 3x minus 2. And this should look familiar because you actually have problems like this last chapter. So remember how we do this. I just distribute that x squared to each term here. And I get 3x cubed minus 6x squared. What do I do now? Do the 5x, yep, to each of these. So 5x times 3x is 15x squared. 5x times negative 2 is negative 10x.
Actually, negative 6 squared.
How did I get what?
Negative 6 squared.
Because that's x squared times, oh, it should be negative 2x squared. Sorry, that should be a negative 2. Okay. All right, and then last but not least, let's go ahead and look at our negative 2 if I distribute that. What do I get there?
Negative 6x plus 4.
Negative 6x plus 4. So now I'm just looking to combine like terms. So I have 3x cubed,
Plus 13x squared.
13x squared,
Minus 16x.
Yep.
Plus 4.
plus 4. And there you go. So far, so good? Okay, let's look at the division. F over g of x. Okay. So basically what that means is I'm going to take the f function, which is x squared plus 5x minus 2. By the way, can I factor that at all? No. 2 factors of 2 that differ by 5 can't do that, so I'm going to leave it alone. Over 3x minus 2. No, you can't cancel anything out. You can't cancel the 2's. It's basically what the division wants. You're not going to do a whole lot. But we've got one thing we've got to find. And that's we've got to find where the denominator equals 0.
So is that the answer?
Almost. We've got to find where the denominator equals 0. And so basically what you're going to do is you're going to take that denominator, set it equal to 0, and I'm going to solve. Okay? So add 2, and you get 2, and then divide by 3. So now what we need to state here is that x cannot equal 2/3. And yes, you need that. Okay? X cannot equal 2/3. What do you think so far?
Is it getting hard?
No, we're going to look at something new called composition. Okay, composition of functions. I'm going to show you a little trick that I use on these. Okay, and these actually relate to some of the ones you did yesterday on your test. But basically, the composition of functions, it's the results of one function are used to evaluate a second function. And so you're probably wondering what this symbol is. It's just an open circle. Okay? So it's kind of like a time sign, but it's open. And so what that means is that's read as f of g of x. Exactly as you see it. F of g of x. And what that's defined to be is, notice I've got an f here, and then I've got g of x in parentheses. And this is a pretty important statement, because if you can remember this, it should be fine. You might also see it written this way. And can somebody tell me how that's going to be read?
G of f of x.
G of f of x, very good. And so, basically, this is what g of f of x means.
Little circle thing just mean of.
Yeah, you could view it as that way. I've had some kids in the past that call this fog and golf. I mean, the 0 or the O isn't as big as the G and the F, but that's how they remember what to do. Okay, so we're going to go ahead and look at a few examples, and then that'll probably finish up for concept. We've got a story problem, and then that's all we're covering today. Okay. So let's go ahead and look at the next slide. For each pair of functions, find f of g of x and g of f of x. So I'll let you go ahead and get those points down if you want. And then I'm just going to write something down. I'm not going to start yet, so you've still got time. Okay, now if I look here, order of operations states you always do parentheses first, right? So according to this statement here, where do I start? I start with what? G. Okay, so I'm going to start with the G function. So this is what I'm going to do, because my answers are going to be a bunch of ordered pairs. I'm going to start here with this squiggle. And my first ordered pair in the G function is what? 8, 15. So this is what I'm going to do. I'm going to take my first point, 8, and I'm going to put it down. Now this is where it gets kind of interesting. Because I go 8 to 15, right? I'm going to now go up to the F function, and where do you see 15? What is it with? 11. So my ordered pair, when I compose them, is 8, 11. Okay, so let's go ahead and go to the second point. What is my first coordinate going to be?
5.
5. So I'm going to go 5 to 1, and then what?
8.
1 to 8. Very good. So 5 goes with 8. So basically, it's like you're leaving out those middle ones. So my next point, we'll start with what point? 10. So it's going to go 10 to, and then, so 9 will be my last point. And then, just for kicks, somebody tell me what that last point will be?
9, 13.
913. Nice job. So there is what f of g of x is. Okay? Now we're going to do the same thing with g of f of x, except for instead of starting with the g function, I'm going to start with the f function, because the f is in parentheses. So here we go. The f function, I'm going to start with 1. Okay? 1 goes to 8, and then 8 goes to 15.
Oh,
Okay? All right, so the next one on the f function is going to be at 0. And then where is 0 going?
13.
There's no 13, so 0 is going nowhere. Okay? What about the next one, 15? 15 is 15's not going anywhere. What about 14?
0.
14 is going to 0, right? So there you go.
Does this get harder?
Actually, I think this is harder than what we're doing next. Okay, so now what we're going to do is instead of looking at ordered pairs, we're going to look at functions. Same instructions, find f of g of x and g of f of x. So f of x is 2a minus 5. G of x is 4a. Our instructions are to find f of g of x and g of f of x. So here's f of g of x. Remember, that means this right here. Order of operations states we always do what first? Parentheses. So g of x. So what I'm going to do is in place of g of x, I'm going to put the g of x function, which is what? 4a. Okay, because that's what g of x equals. It equals 4a up there at the top. So now this is going to look real similar to what you had on the last test. Okay, at that bottom of the page you had to find like p of x, and they would say like p of 3a. So this says I'm going to find f of 4a. So I'm going to go to the f function, and in place of this, what am I going to put?
4A.
4a. So I'm going to take 2 times 4a minus 5. And what will my answer be? 8a minus 5. That's your first one. You okay?
Yeah.
On the next one, now we're going to do g of f of x. What's the first thing I'm going to replace? The parentheses, right. So f of x. And what am I going to put in place of f of x? 2a minus 5. So now I'm going to go to the g function, right here. And in place of this right here, what am I going to put? Right, so what that means is I've got my 4, parentheses, 2a minus 5. So now I need to distribute that 4, and what do you get? 8a minus 20. That is f of g of x and g of f of x. Let's look at another one, and then we'll have a story problem. Okay, so let's start. I'm just going to write it this way. Okay, because I know that's where I'm going to start. So really, and you can, it doesn't matter how you write. This means f of what? X minus 6. So now, wherever I see x in the f problem, so I see an x here, I'm going to put x minus 6. So basically, x minus 6 quantity squared plus 2. Now, this is a mistake that gets made a lot. A lot of you write this down as x squared plus 36. That's not right. Okay? X minus 6 quantity squared really means this. Okay? So make sure you get that down, because what you're doing is you're missing those middle terms all the time. So now, if I take first times first, I get x squared. Outer, I get negative 6x. Inner, I get. Last, I get plus 36. And then plus 2. So what's my final answer? X squared minus 12x plus 38. And there you go. I want you to try g of f of x for me. Okay, just jot it down on a sheet of scratch paper if you need to. But I want you to try g of f of x. Okay, so you should have had g of x squared plus 2. Okay. So now what I'm going to do is I'm going to plug x squared plus 2 right here. So I really get x squared plus 2 minus 6. So what does your final answer look like? X squared minus 4. So just because that first one was a little longer doesn't mean the second one's going to be longer. Okay. Last thing we're going to look at is a story problem. Sounds to Go, okay, offers both an in-store $35 rebate and a 15% discount on a digital audio player that normally sells for $300. Which provides the better price? Taking the discount before the rebate or taking the discount after the rebate?
Before, because it's a big.
So let's figure it out. So we got $300, right? So let's take off 15%. What would 15% of 300 be? $45. So if I subtract $45, because this is my 15% discount, I'm going to now pay $255. And then if I subtract the rebate, my total bill will be what? $220. So now let's try it. $300 minus the rebate first. And I get what? $265. I'm now going to take that, okay, and subtract 15% of that. 15% of that is going to be $39.75. So what do you end up paying now? Like $226, isn't it? $220 what? $225.25. So let's reason. Why is it better to do this? The $35 is a blanket amount.
Because you're taking.
Okay. Yeah. You're 15% of 300 here, where I started with, is a lot more than 15% of 265. So when you ever have that again, and trust me, because it happens when you go through stores, okay, you always give them this at the very end after they've done all their sales. Now some stores already have it figured in their cash register automatically, where they're going to end up going this route. But you can end up doing it, you know, other ways in like other areas, like when you buy cars, things like that. So here you go. Pages 389, 390, 8 through 16 the evens, 28 through 36 the evens, and 41 through 46 all.